Welcome to Calming Cosmos. I'm so glad you're here with us tonight. Before we begin, I'm curious, where are you right now? Perhaps you're lying in a quiet bedroom. The lights already dimmed. The world outside slowing down. Maybe you've settled into a familiar couch, wrapped in a blanket, letting the day gently loosen its grip. Or maybe, just for a moment, you're gazing upward, thinking about the night sky above you and the vast universe beyond it. Wherever you are in this world, wherever your body has chosen to rest tonight, you are exactly where you need to be. Take a moment now to notice how you're positioned. Feel the surface beneath you, supporting your weight without effort. Let your shoulders soften, your jaw unclench, your hands rest naturally. There's nowhere else you need to be right now. Nothing else you need to accomplish. This time belongs to you. If you enjoy these peaceful explorations of the universe, a gentle reminder that a like and a subscription really do help this sleepy little channel continue. And if you're already subscribed, thank you. Truly, your support means more than you might realize, and it allows these quiet journeys to keep unfolding. Night after night. Tonight, we're going on a journey together, a slow, unhurried drift through one of the cosmos's most mysterious and misunderstood phenomena. Black holes, not as something frightening, not as monsters hiding in the darkness, but as natural structures, calm, predictable, following the same physical laws as everything else in the universe. We'll explore what black holes are, how they form, and why they're very different from the dramatic portrayals often seen in movies and television. We'll gently examine the strange behavior of light near their edges, the way space and time bend and flow around them, and the quiet truth that black holes are simply another expression of gravity, taken to its natural extreme. There's no pressure to stay awake for this entire journey. In fact, if you drift off along the way, that's perfectly wonderful. That's exactly what this experience is designed for. Let the words wash over you like gentle waves on a calm shore. There's no test at the end, no need to remember details or definitions. Just allow yourself to float peacefully through the cosmos. Black holes are not cosmic predators lying in wait. They don't roam the universe hunting stars and planets. They don't tear galaxies apart indiscriminately. They are quiet objects, stable, patient, governed by the same laws that guide falling leaves, orbiting moons, and spinning planets. Tonight, we'll approach them with curiosity, with calm, and with a sense of quiet wonder. So take one more slow breath in, and as you exhale, feel your thoughts begin to settle, your breathing soften, your awareness gently expand. And let's begin. A black hole is a region of space where gravity has become so intense that nothing can escape once it passes a certain boundary, not even light. That boundary has a name: the event horizon. It's important to understand. The event horizon is not a physical surface. It's not a solid shell or a wall you could touch. Instead, it's a mathematical boundary, a point in space where the geometry of space-time becomes so curved that all possible paths lead inward. Outside the event horizon, movement is flexible. You can move closer or farther away. You can orbit. You can escape. At the event horizon itself, that freedom disappears. To understand this, imagine standing on a gently sloping hill. At first, you can walk in any direction, uphill, downhill, sideways. As the slope becomes steeper, walking uphill requires more effort, but it's still possible. Now imagine the slope becoming so steep that no matter which way you try to walk, every direction leads downward. There is no longer an up. That's what space-time becomes like at the event horizon of a black hole. Space itself tilts inward. The future, for anything that crosses that boundary, points toward the center, not because something pulls it, but because the structure of space-time allows no alternative path. Light behaves the same way. Photons, which normally travel in straight lines at the ultimate speed limit of the universe, find those straight lines bent, curved, redirected. Near the event horizon, even light's fastest possible path leads inward, and so no light escapes to carry information back out. That's why black holes appear black, not because they absorb light like dark paint, but because no light ever returns to our eyes. But black holes were not always black holes. They have origins, histories, long cosmic stories that begin with stars. Most black holes we know about form from massive stars, stars far larger than our sun. These stars live fast, energetic lives, burning through their nuclear fuel at incredible rates. For most of a star's lifetime, it exists in balance. In its core, nuclear fusion produces enormous heat and pressure, pushing outward. Gravity, patient and constant, pulls inward. These two forces remain in equilibrium, and the star shines steadily, sometimes for millions or billions of years. But fusion requires fuel. Hydrogen is fused into helium, helium into heavier elements like carbon and oxygen. Eventually, silicon and iron. And here, the story changes. Iron cannot produce energy through fusion. When a massive star's core becomes rich in iron, the outward pressure collapses. Fusion stops, and gravity, finally, takes full control. The core collapses, not slowly, not gently. In a fraction of a second, a region once comparable in size to Earth compresses down to something only a few kilometers across. The outer layers of the star rebound violently, exploding outward in a supernova, a brilliant flash, so luminous it can briefly outshine an entire galaxy. But we're not focused on the explosion tonight. We're focused on what remains. If the collapsing core is massive enough, more than about 3 times the mass of our Sun, no known force can stop it, not neutron pressure, not electromagnetic forces. The core continues collapsing, becoming smaller, denser, more extreme, until it forms a singularity, a point where density becomes infinite, and the equations of physics, as we know them, break down. Around this singularity, space-time curves so dramatically that the event horizon forms. The black hole is born, and then it simply exists. It doesn't grow unless matter falls into it. It doesn't shrink unless it emits radiation over unimaginably long timescales. It just sits there, warping the fabric of space, a permanent imprint left by a star's final moment. One of the most common misunderstandings about black holes is the idea that they suck things in. They don't. A black hole's gravity, at a distance, behaves exactly like the gravity of any other object with the same mass. If our Sun were magically replaced by a black hole of identical mass, Earth would continue orbiting exactly as it does now. The only difference would be darkness and cold, not a sudden plunge inward. The danger of a black hole exists only very close to it, near the event horizon. For a black hole with the Sun's mass, that horizon would be only about 3 kilometers across. You would have to get extraordinarily close before escape became impossible. And so, black holes are not cosmic vacuum cleaners. They are quiet, compact objects, influencing their surroundings only when something wanders too near. Time behaves strangely near a black hole. According to Einstein's theory of general relativity, gravity doesn't just curve space, it also curves time. The stronger the gravitational field, the slower time flows. Near the event horizon, this effect becomes extreme. If you could somehow hover just above a black hole's event horizon and look outward at the universe, you would see time accelerating, stars aging rapidly, galaxies evolving. Billions of years could pass, while only moments tick by for you from far away. An observer watching someone fall toward a black hole would see something very different. They would see the falling person slow down, their image stretching, reddening, fading. The person would appear to freeze, suspended at the event horizon, never quite crossing it. But from the perspective of the person falling, nothing unusual happens at that boundary. They cross it smoothly, without noticing. Time flows normally for them, even though to the outside universe, they never seem to arrive. Both perspectives are correct. This duality is one of the deepest lessons black holes teach us. Reality depends on where you are, how you're moving, and how gravity shapes space-time around you. The mathematics that describe black holes were discovered long before anyone believed they were real. In 1915, Albert Einstein published his theory of general relativity. Within months, a physicist named Carl Schwarzschild found an exact solution to Einstein's equations. It described a region of space where gravity became infinite and light could not escape. At the time, it seemed absurd, a mathematical curiosity, something nature would surely avoid. But nature had other plans. Decades later, astronomers began detecting intense X-ray sources in space. One of them, Cygnus X1, revealed the unmistakable gravitational signature of a black hole, too massive, too compact, invisible, except for its effects on a nearby star. Since then, black holes have gone from theoretical oddities to confirmed residents of the universe. Thousands have been identified, and millions more likely exist, quietly drifting through galaxies. Unseen, they are not rare, they are not exotic exceptions. They are part of the universe's natural architecture. And as we continue this journey, we'll explore how black holes interact with their surroundings, how they glow without shining, and how they shape the cosmos on the grandest scales. For now, rest with this thought. Black holes are not places of chaos. They are places of order taken to an extreme. Gravity, doing exactly what it has always done, following the rules without exception. And in that, there is something deeply calming. Let's drift onward now, deeper into the quiet space surrounding a black hole, and explore what happens when matter wanders too close. A black hole on its own, floating in empty space, would be nearly impossible to detect. It emits no light. It makes no sound. It announces nothing about its presence. Space around it appears calm, ordinary, unchanged. But the universe is rarely empty. Gas clouds drift between stars. Dust moves slowly through galaxies. And sometimes, a black hole finds itself near a companion star, bound together by gravity, locked in a long orbital dance. When that happens, the black hole begins to reveal itself. Matter pulled from a nearby star, or gas drifting through space, does not fall straight in, because matter almost always has some motion, some sideways velocity. And so instead of plunging directly toward the center, it spirals. Imagine water circling a drain. It doesn't drop straight down. It curves, forming a whirlpool, moving faster and faster as it approaches the center. Around a black hole, something similar happens. The infalling matter forms a flattened, rotating structure called an accretion disk. This disk is not solid. It's made of countless particles, atoms, ions, all orbiting the black hole at incredible speeds. As they spiral inward, they collide, they rub against one another, and those interactions create friction. Friction creates heat, and near a black hole, that heat becomes extreme. The inner regions of an accretion disk can reach temperatures of millions of degrees. At those temperatures, matter glows intensely, not gently, like a candle or a star, but fiercely, emitting X-rays, ultraviolet radiation, and visible light. This is one of the great ironies of black holes. The black hole itself remains invisible, but the matter around it becomes some of the brightest material in the universe. This glowing disk is often how we detect black holes. We don't see the hole. We see the light from matter just before it disappears. The disk is not smooth or calm. It's turbulent, chaotic. Magnetic fields thread through it, twisting, reconnecting, releasing bursts of energy. These magnetic fields play a crucial role in shaping what happens next. In some systems, part of the infalling matter never reaches the black hole at all. Instead, it's redirected. Along the black hole's rotational axis, narrow beams of particles form. These are relativistic jets, focused streams of matter and energy, accelerated to nearly the speed of light, shooting outward in opposite directions. These jets can extend for thousands, or even millions, of light years. They pierce through galaxies, illuminating intergalactic space. From Earth, they appear as brilliant streaks, marking the presence of an active black hole far away. But tonight, we don't need to focus on their power. We can simply acknowledge their existence and return our attention to the calmer motion of the disk itself. As matter spirals inward, it moves faster and faster. The closer it gets to the black hole, the greater the orbital speed required to stay in motion. Eventually, the disk reaches a region where stable orbits are no longer possible. This region is called the innermost stable circular orbit. Inside this boundary, matter can no longer orbit peacefully. It plunges inward. The final descent begins. Just outside the event horizon, something remarkable occurs. There is a region known as the photon sphere. Here, light itself can orbit the black hole. Photons, traveling at the speed of light, curve around the black hole, tracing circular paths, not escaping, not falling in, just endlessly circling. This doesn't last forever. The orbits are unstable, a tiny disturbance, and the photon either escapes or falls inward. But for a brief time, light can dance around the edge of darkness. Below this region lies the event horizon. Cross it, and there is no return. For a distant observer, matter approaching the event horizon appears to slow down. Its light becomes redder, stretched to longer wavelengths. The glow fades until it disappears entirely. From the outside, the matter never seems to cross the boundary, but from the matter's own perspective, the fall continues smoothly. There is no sudden change, no warning sign. Space remains continuous. This difference in perspectives is one of the most profound aspects of black holes. There is no single story, only viewpoints shaped by gravity and motion. In 2019, humanity saw something extraordinary. The Event Horizon Telescope, a network of radio observatories spread across Earth, combined their data to create the first direct image of a black hole's shadow. The target was the supermassive black hole at the center of the galaxy M87. What we saw was a dark circle surrounded by a glowing ring. That ring was light from the accretion disk, bent around the black hole by gravity. Some of that light originated behind the black hole, but was curved forward, reaching us after looping through warped space-time. It was not a photograph in the traditional sense, but it was real. A confirmation that black holes are not just equations, but physical objects shaping reality. For our gentle journey tonight, the image offers reassurance. Black holes are not voids of chaos. They are surrounded by structure, by motion, by light. They are dynamic, but not wild, extreme, but not unpredictable. And when the supply of matter ends, the activity fades. If gas runs out, the accretion disk dims, the jets switch off, the black hole becomes quiet once more, invisible again, detectable only through its gravitational influence. Most black holes in our galaxy are in this quiet state. They drift silently through space, not feeding, not glowing, just existing. They warp space-time gently, bending the paths of passing stars and light without announcing themselves. Now, let's imagine something a bit more personal. Imagine you are falling toward a black hole, not a supermassive one, but a smaller black hole, perhaps 10 times the mass of the Sun. At first, everything feels normal. Space looks ordinary. You see stars around you. You can still send signals outward. Gravity feels stronger, but manageable. As you approach, gravity increases, but not uniformly. The part of your body closer to the black hole experiences a stronger pull than the part farther away. This difference is known as a tidal force. On Earth, tidal forces are gentle. They move oceans. They raise tides. Near a black hole, they become intense. As you fall feet first, your feet are pulled more strongly than your head. Your body begins to stretch, slowly at first, then more dramatically. Physicists have given this process a memorable name: spaghettification. It sounds playful, but the reality is severe. The stretching continues until molecular bonds break. Atoms are pulled apart. Matter is elongated into thin streams. For a small black hole, this happens well before the event horizon. But for a supermassive black hole, the story is different. Because the event horizon is much larger, the tidal gradient near it is gentler. You could cross the event horizon of a supermassive black hole without feeling anything unusual at all. No pain, no stretching, just continued falling. Inside the event horizon, all paths lead inward. Space and time exchange roles. The singularity lies in your future, as inevitably as tomorrow lies in yours now. From your perspective, the journey is short. For a stellar mass black hole, the time between crossing the horizon and reaching the singularity is less than a second. From the outside, you never cross at all. Both descriptions are correct. This is not a paradox of logic, but a feature of space-time. Reality near a black hole is layered, dependent on perspective, shaped by gravity. And perhaps that's a comforting idea. The universe does not insist on a single narrative. It allows multiple truths, coexisting peacefully. Black holes remind us that our everyday intuition is not the final authority. Space can curve, time can slow, light can orbit, and all of it follows consistent rules, even when those rules feel unfamiliar. So as we continue, let these ideas rest lightly in your mind. You don't need to solve them. You don't need to remember them. Just allow them to pass, like stars drifting across a night sky. Let's drift a little farther now, away from the edge of falling, and toward the wider role black holes play in the universe itself. Black holes are not isolated curiosities. They are woven deeply into the structure of the cosmos, quietly influencing, shaping, and sometimes guiding the evolution of galaxies over billions of years. At the center of nearly every large galaxy we've observed, there resides a supermassive black hole. Our own Milky Way is no exception. Hidden behind clouds of dust and gas, far beyond our direct line of sight, sits a black hole known as Sagittarius A. Sagittarius A contains about 4 million times the mass of our Sun. All of that mass compressed into a region smaller than the orbit of Mercury. And yet, from a distance of 26,000 light-years, we can measure its presence with precision. How? By watching stars dance. Near the center of the galaxy, stars move extraordinarily fast. Some complete their orbits in just a few years. Their paths curve sharply, accelerating as they approach the unseen center, slowing as they swing away. By tracking these motions over decades, astronomers have mapped the gravitational field at the galactic core. There is only one explanation: a massive, compact, invisible object, a supermassive black hole. What's remarkable is how calm this center appears. Sagittarius A is currently quiet. It's not consuming large amounts of gas. It's not producing powerful jets. It simply exists, holding the galaxy's core together through gravity alone. This is important to understand. A supermassive black hole does not constantly devour everything around it. Most of the time, it is dormant. Galaxies do not fall inward. Stars do not spiral helplessly into the center. Orbits remain stable. Structures persist. But there are times when a galaxy's central black hole becomes active, when gas clouds drift too close, or when galaxies collide and disturb each other's structure. material can flow toward the center. Accretion begins, and the black hole awakens. The accretion disk forms. Radiation floods outward. Jets ignite. In this active state, the black hole becomes the brightest object in its galaxy, brighter than all its stars combined. These systems are known as active galactic nuclei. From Earth, they appear as quasars, blazing beacons visible across billions of light years. When we observe distant quasars, we are often looking back to the early universe, when galaxies were young and black holes were growing rapidly. And here's something deeply interesting. The growth of a galaxy and the growth of its central black hole appear to be linked. Observations show a tight relationship between the mass of a galaxy's central black hole and the mass of its bulge of stars. This suggests coevolution. As the galaxy grows, so does the black hole. As the black hole becomes active, it influences how many stars the galaxy can form. How does this work? Through feedback. When a black hole accretes matter, it releases energy. That energy heats surrounding gas. It can push gas outward, preventing it from cooling and collapsing into new stars. In this way, the black hole regulates star formation. It acts as a cosmic thermostat. Too much gas falls in. The black hole flares, pushing gas away. Too little gas. The black hole quiets, allowing stars to form again. This balance shapes galaxies over cosmic time. Without black holes, galaxies would look very different. Simulations that exclude them produce galaxies that are too dense, too massive, too bright. Add black holes, and the simulations begin to resemble the universe we actually see. So in a very real sense, black holes are creators. They sculpt the environments where stars form. They influence the distribution of matter. They help determine the structure of galaxies. And since planets form around stars, and life arises on planets, black holes have indirectly shaped the conditions that allow life to exist at all. That's a profound thought. Now let's shift our attention from galaxies to motion itself. Black holes are not static. They move, they orbit, they merge. When two black holes form near each other, perhaps from a binary star system, they can become gravitationally bound. They spiral around one another, slowly at first, then faster and faster as they lose energy. Where does that energy go? Into gravitational waves. Gravitational waves are ripples in space-time itself, predicted by Einstein, but undetected for a century. They are not vibrations of matter, but distortions of space and time, propagating outward at the speed of light. In 2015, humanity detected gravitational waves for the first time. The signal came from two black holes, each about 30 times the mass of the Sun, merging more than 1 billion light years away. As they spiraled together, they released enormous energy. In the final fraction of a second, They converted the mass of several suns directly into gravitational waves. Those waves traveled across the universe, stretching and compressing space-time until they reached Earth. When they passed through our planet, they changed the length of specially designed detectors by less than the width of a proton. And yet, we measured it. For the first time, we didn't just see the universe, we heard it. Since then, dozens of black hole mergers have been detected, each one a quiet message from deep space, a record of objects colliding far beyond our reach, but still connected to us through space-time. Black holes are not silent after all. They speak through gravity, and through these signals, we learn about their masses, their spins, their origins. We learn how often they merge and where they form. We learn about the population of black holes hidden throughout the cosmos. Many black holes exist in complete darkness. They are not feeding, they are not glowing. They drift invisibly through galaxies. We know they're there, not because we see them, but because of how stars evolve, how supernovae occur, how gravitational waves are detected. Our Milky Way alone may contain millions of stellar mass black holes. Most are quiet, unnoticed, passing through space without interaction. Occasionally, one passes close to a star or through a cloud of gas, and for a brief time, it becomes visible. Accretion begins. X-rays flare. Then the fuel runs out, and the black hole fades back into darkness. These transient events give us glimpses, brief windows, into an otherwise hidden population, and they remind us that the universe contains far more than what we can see. Light is only one messenger, gravity is another, and black holes communicate almost entirely through gravity. Now, let's pause for a moment and consider something deeper. Black holes challenge our understanding of information. When something falls into a black hole, all information about its structure appears to vanish from the outside universe. Its shape, composition, quantum state, gone forever. But quantum mechanics tells us information cannot be destroyed. This conflict is known as the black hole information paradox. Does information truly disappear? Or is it somehow encoded at the event horizon? Or released slowly through Hawking radiation? Physicists have debated this for decades. No final answer yet exists, but the paradox has driven enormous progress, pushing us toward deeper theories of reality. Black holes, by refusing to fit neatly into our frameworks, force us to think more carefully, more creatively, more humbly. They remind us that our knowledge is incomplete, that the universe still holds secrets. And that's not something to fear, it's something to appreciate, because mystery is what keeps discovery alive. So as we float here, surrounded by these ideas, allow yourself to feel the calm beneath them. The universe is not hostile. It is structured, orderly, lawful. Even at its most extreme, it follows rules, and black holes are simply one of nature's most elegant expressions of those rules. Let's slow our pace just a little more now and turn our attention inward towards some of the deepest questions black holes raise, not just about space, but about reality itself. Black holes are not only objects in space, they are tests of our understanding of physics, tests of how far our theories can stretch before they begin to tear. At the heart of every black hole lies something we call a singularity. This word often sounds dramatic, but in physics, it has a very specific meaning. A singularity is a point where our equations stop working, where quantities like density and curvature become infinite, where space and time lose their familiar meaning. It does not necessarily mean a physical point you could visit. It means the limits of knowledge. Einstein's theory of general relativity describes gravity with extraordinary accuracy. It predicts planetary orbits, gravitational lensing, time dilation, and the existence of black holes themselves. But at the singularity, general relativity breaks down. The equations return infinities, and infinities are signals. They tell physicists something is missing. Near the singularity, gravity is not the only force that matters. Quantum effects, the rules that govern atoms and particles, must become important. But general relativity does not include quantum mechanics, and quantum mechanics does not describe gravity. We have two powerful theories, each correct in its domain, but incompatible at extremes. Black holes exist precisely at that boundary. They are where gravity becomes quantum, and where our understanding runs out. This is why black holes are so important to science, not because they destroy things, but because they expose gaps in our knowledge. They show us where new physics must exist. For decades, physicists have searched for a theory of quantum gravity, a framework that unites general relativity and quantum mechanics into a single description of reality. String theory, loop quantum gravity, holography. Many approaches exist. None are complete. None are experimentally confirmed. But black holes guide them all. One idea that has emerged is that information is not lost in black holes, but stored in subtle ways at the event horizon. This idea is known as the holographic principle. It suggests that all the information contained within a volume of space can be described by information encoded on its boundary, much like a hologram, where a two-dimensional surface encodes a three-dimensional image. In this view, the event horizon of a black hole is not empty. It is not merely a mathematical line. It is a surface with structure, with microscopic degrees of freedom, with information. Everything that falls in leaves an imprint, not inside, but on the boundary. This idea arose from attempts to solve the black hole information paradox, And while it is not fully proven, it has reshaped how physicists think about space-time itself. It suggests something profound. That space may not be fundamental. That volume may emerge from information. That reality, at its deepest level, might be encoded. Black holes, once seen as places where physics ends, have become windows into how reality might truly work. And there's something quietly beautiful about that. Now let's return gently to something more tangible. Let's consider time again. We've already seen that time slows near a black hole, but the effects go deeper. Outside the event horizon, time behaves strangely but predictably. Clocks closer to the black hole run slower than clocks farther away. This has been measured experimentally, not near black holes, but near Earth. Atomic clocks at different altitudes tick at different rates. Gravity slows time. Near a black hole, this effect becomes extreme. But inside the event horizon, the roles of space and time begin to switch. Outside the black hole, you can choose where to go in space, but time moves forward inevitably. Inside the event horizon, you can no longer choose your future. The singularity lies ahead in time, just as tomorrow lies ahead for us now. You cannot avoid it, not because of force, but because of geometry. Inside the horizon, moving toward the singularity is not a direction in space. It is a direction in time. And that's a strange idea. It means falling into a black hole is not like falling into a pit. It is more like moving forward through time toward an unavoidable event. This reframing removes some of the fear. It's not violence, it's inevitability. Just as we all move forward in time, black hole interiors move toward their singularities. Now, let's step back again and talk about something even quieter: Hawking radiation. In the 1970s, Stephen Hawking combined quantum mechanics with general relativity and discovered something unexpected. Black holes are not completely black. Near the event horizon, quantum fluctuations occur. Empty space is not truly empty. Particle-antiparticle pairs constantly appear and annihilate, even in a vacuum. Normally, these pairs vanish instantly, but near the event horizon, something different can happen. One particle falls into the black hole, the other escapes. To a distant observer, it appears that the black hole has emitted a particle. Slowly, imperceptibly, the black hole loses mass. This process is incredibly weak. For stellar mass black holes, the radiation is far colder than the background radiation of the universe. They absorb more energy than they emit. They grow, not shrink, but over unimaginable timescales, trillions upon trillions of years. Hawking radiation wins, black holes evaporate. Even supermassive black holes, containing billions of solar masses, will eventually fade away. Slowly, quietly, particle by particle. This has enormous implications. It means black holes are not eternal. They are temporary states, long-lived but finite. In the far future of the universe, long after the last stars have burned out, long after galaxies have drifted apart, black holes will be among the final massive objects remaining, and then even they will vanish, leaving behind a cold, dark, dilute universe, expanding forever. This vision of the future can feel unsettling, but it can also feel peaceful, a slow unwinding. No explosions, no catastrophes, just gradual fading, the universe exhaling. Now let's return once more to rotating black holes. Rotation adds richness, complexity, subtlety. A rotating black hole drags space-time around with it. This effect, called frame dragging, is not unique to black holes. Earth itself drags space-time slightly as it rotates. Satellites have measured this, but near a black hole, the effect becomes extreme. Outside the event horizon lies a region called the ergosphere. In this region, space-time is dragged so strongly that nothing can remain stationary. Everything is compelled to rotate with the black hole. You could still escape from the ergosphere, but you could not stand still. The ergosphere allows something remarkable: energy extraction. Through processes like the Penrose process or magnetic interactions in accretion disks, rotational energy can be removed from a black hole. The black hole slows slightly. Energy flows outward, powering jets and radiation. Black holes are not just sinks, they are engines, and these engines shape galaxies. Now pause and notice how your breathing feels. There's no urgency here, no need to track every idea. Just let them drift by, one at a time. Black holes, for all their extremity, are orderly, governed by precise mathematics. They do not rage, they do not hunt, they follow rules. And those rules are the same ones that govern everything else. Gravity, energy, time, the same principles that guide planets in their orbits, guide matter into black holes. The same conservation laws that govern your body govern the universe. You are not separate from this story. You are part of it. And as we continue, we'll move toward reflection, toward meaning, toward how these cosmic truths connect gently to us. But for now, rest here, floating between stars, between ideas, between breaths. Let's drift a little farther now, away from equations and horizons, and toward a quieter understanding of what black holes mean in the long story of the universe. So often, black holes are spoken about as endings, as places where things disappear, as cosmic dead ends. But in reality, black holes are not endings at all. They are transitions. They are chapters within a much larger cycle. To see this clearly, we need to zoom out, far out, beyond individual stars, beyond single galaxies, and look at the universe as a whole, evolving slowly over time. The universe began in a hot, dense state. Matter and energy expanded outward over billions of years. Gravity gathered material into stars, stars into galaxies, galaxies into clusters. Structure emerged, not in spite of gravity, but because of it. Black holes are part of this same process. When massive stars die, black holes are born. When galaxies grow, their central black holes grow with them. When galaxies collide, their black holes eventually merge, settling into a new equilibrium. Nothing about this is chaotic. It is slow, measured, lawful. Black holes are simply gravity, doing what gravity always does, when given enough mass in a small enough space. And gravity is a gentle force. It may not feel that way when we talk about extremes, but gravity works patiently. It pulls softly, steadily, over long time scales. It builds stars, forms planets, and yes, creates black holes, and there is no malice in it, no intention, just consistency. Now let's think about scale. A black hole can be massive beyond imagination. Millions, billions of times the mass of the sun. And yet, compared to a galaxy, it is tiny. Compared to the universe, it is insignificant. Even the largest black holes occupy a minuscule fraction of cosmic volume. Most of space is empty, calm, vast beyond comprehension. This perspective matters because when we hear about black holes, it's easy to imagine them dominating the universe, but they don't. They are rare, sparse, isolated. The cosmos is not filled with danger. It is filled with distance, and distance is safety. Our nearest known black hole is thousands of light years away. Even that one is quiet, dormant. It poses no threat. Black holes do not wander into solar systems. They do not roam galaxies looking for prey. They follow orbits, like everything else, predictable, stable, so we can let go of fear. Black holes are not hazards in our daily lives. They are distant teachers, revealing truths from afar. Now let's consider something deeply subtle. Entropy. Entropy is a measure of disorder, or more accurately, of how many microscopic configurations correspond to a macroscopic state. It is a measure of possibility. The universe, over time, tends toward higher entropy. Systems spread out, energy disperses, gradients flatten. Black holes, surprisingly, have entropy. In fact, they have enormous entropy. Physicist Jacob Bekenstein showed that a black hole's entropy is proportional, not to its volume, but to the area of its event horizon. This was a shocking discovery. It suggested that black holes contain the maximum entropy possible for a given region of space. In other words, nothing can be more disordered than a black hole. And yet, Black holes are incredibly simple. They can be fully described by just a few properties: mass, spin, charge. This contrast, simplicity on the outside, complexity hidden, is profound. It tells us that black holes are not voids. They are packed with microscopic possibilities. Information, in some form, is there, hidden, encoded, waiting. This again points us toward the idea that reality may be informational at its core, that space-time itself may emerge from deeper principles. Black holes are not holes in reality. They are mirrors, reflecting our incomplete understanding back to us. Now let's return gently to something human. When we hear about time slowing near black holes, about falling inward, about inevitability, it's natural to draw parallels with our own experience. Time flows for us too, forward only, unstoppable. We cannot go back. We cannot stop it. We move, moment by moment, toward the future. In that sense, we all live inside our own event horizons, not physical ones, but temporal ones. The past is unreachable. The future awaits. And yet, we don't fear this. We accept it. We live within it. Black holes remind us that this flow is universal, not unique to us. Time moves forward everywhere, shaped by gravity, shaped by mass, shaped by the universe itself. Even the most extreme objects follow the same arrow of time. There is comfort in that, because it means we are not anomalies. We are not outsiders. We are expressions of the same cosmic rules. Now consider quiet black holes. Most black holes are not dramatic. They do not glow. They do not emit jets. They drift silently through space, invisible. They are only detectable when they interact with something else. This is true of many things. Much of the universe is quiet. Much of reality is subtle. Most of what exists does not announce itself, and yet it matters. Quiet black holes still warp space, still influence orbits, still shape long-term dynamics. Their presence is felt, even when unseen. This mirrors something deeply human. Much of what shapes our lives is quiet. Habits, thoughts, slow changes, background influences. They don't announce themselves loudly, but over time, they matter more than dramatic moments. The universe works the same way. Now let's think about connection. Black holes are connected to everything around them, through gravity, through space-time, through shared history. The matter that falls into a black hole was once part of stars. Those stars were formed from gas clouds. Those clouds formed from earlier generations of stars, all recycled, all connected. Nothing appears from nowhere. Nothing disappears completely. Even when matter falls into a black hole, it remains part of the universe. Its energy contributes to the black hole's mass. Its gravitational influence remains. Its information perhaps hidden, but not erased, and over long timescales, through Hawking radiation, that energy returns to the universe, slowly, quietly, inevitably. The universe does not waste, it transforms. This is one of the most peaceful ideas science offers. Nothing is truly lost. Everything changes form. Now let's rest with one final idea in this section. Perspective. From far away, black holes look calm, stable, simple. From close up, they are extreme, curved, strange. Both views are true. The same is true in life. From a distance, moments blur together, patterns emerge, meaning appears. From close up, things can feel intense, overwhelming, uncertain. Black holes teach us that distance matters, perspective matters, and stepping back often reveals calm where we expected chaos. So if your thoughts feel heavy tonight, if your day felt dense, imagine zooming out. Let the scale expand. Let the universe widen. Your worries are small, not because they don't matter, but because the universe is vast. And within that vastness, there is room to rest. There is room to breathe. There is room for peace. As we continue drifting through these ideas, it becomes clear that black holes are not isolated events in the universe, but participants in long, slow, cosmic conversations. Every black hole exists within a context, a neighborhood of stars, gas, dust, and time itself. Nothing forms alone. When a black hole settles into its quiet existence, it carries with it the memory of what came before, not in a conscious way, but in a physical one. Its mass reflects the star that collapsed. Its spin reflects the rotation it inherited. Its surroundings reflect the environment that shaped it. Black holes remember through gravity. Gravity does not forget. It records mass. It preserves motion. It carries history forward. When a star collapses, its gravity does not vanish. It concentrates. The same pull that once held planets in orbit now curves space-time more deeply. The story continues, just in a different form. This continuity is important because it tells us the universe does not reset. It does not erase. It transforms. Nothing jumps from existence into nothingness. It changes state, shape, behavior, but it remains part of the whole. Black holes are not holes punched into reality. They are folds, concentrations, densities where the same rules apply more strongly, and the universe seems comfortable with that. Now let's consider something gentle, the idea of orbits. Orbits are expressions of balance, motion and gravity, finding agreement. A planet does not fall into its star, nor does it fly away. It moves sideways, endlessly, tracing a path that repeats. Around black holes or orbits exist too. Stars orbit supermassive black holes. Gas orbits stellar remnants. Light itself can orbit briefly near the photon sphere. Even in the presence of extreme gravity, balance is possible. This tells us something subtle. Gravity does not demand collapse. Only proximity changes outcomes. Distance matters, and the universe is mostly distance. This is why black holes are not threats to cosmic order. They do not destabilize everything around them. They fit into the structure, the same way mountains fit into landscapes, influencing, shaping, but not overwhelming. The cosmos is resilient. Now let's gently turn inward again. Your own body exists in balance. Muscles pull, bones resist. Breath flows in, breath flows out. Heart contracts, heart releases. Balance is everywhere. Even sleep is a balance. Between awareness and rest, between control and surrender. Black holes teach us surrender does not mean disappearance. Matter that falls inward does not vanish from the universe. It becomes part of something larger, something deeper, and that idea can feel comforting because rest works the same way. When you sleep, you do not disappear. Your awareness softens, but your existence continues. Processes continue. Repair continues. Integration continues. Sleep is not loss. It is reorganization. Now let's think about silence. Space is silent. Black holes are silent. Most of the universe unfolds without sound. And yet, silence is not emptiness. Silence holds motion. Silence holds energy. Silence holds meaning. The universe does not need noise to function, and neither do you. Quiet is not absence. Quiet is space, allowed. This is why silence feels restorative, because it matches the universe's natural state. Black holes exist mostly in silence. They do not broadcast themselves constantly. They wait. They persist. They allow events to come to them. There is wisdom in that. Now let's rest briefly with uncertainty again. There are things black holes do that we do not fully understand. What happens at the singularity? How information is preserved? How gravity and quantum mechanics truly unite? But uncertainty does not break the universe. It only marks the edge of our knowledge. The universe continues to function perfectly, even where our understanding stops. And this is important because it means you do not need complete understanding to exist peacefully. You do not need to resolve everything tonight. The universe allows mystery. It is built with it. Black holes are not failures of physics. They are invitations to deeper curiosity. But curiosity can rest. You do not need to pursue it right now. Now imagine a black hole in deep space, far from stars, far from gas. No accretion disk, no jets, just mass, curving space-time quietly. Nothing happens there for millions of years, and that is okay. The universe does not measure worth in activity. Stillness has value. This is something many people forget. but the cosmos remembers. Now bring this idea gently back to yourself. You do not need to be productive right now. You do not need to be alert. You do not need to improve anything. You are allowed to be still. The universe does not collapse when you rest. It continues calmly, steadily. Black holes prove this. They are among the most extreme objects we know, and yet they spend most of their existence doing nothing dramatic, just existing, and existence is enough. Now let's soften the edges again. Thoughts may drift, breathing slows, words become less important. This is natural. You are aligning with the universe's pace, slow, measured, unforced. The same pace that governs galaxies, the same pace that governs black holes, the same pace that governs sleep. Nothing is pushing you, nothing is pulling you, just gentle motion, forward, without effort. And wherever you place this moment in your night, it fits, just like this passage fits, quietly, into the larger story. As the universe continues its slow unfolding, black holes remain, patient markers of time itself. They do not rush. They do not hurry toward outcomes. They simply exist, responding only to gravity, mass, and motion. And in that stillness, there is something deeply reassuring, because black holes remind us that the universe is not driven by urgency. It is driven by balance. Even the most extreme objects evolve slowly over millions, billions, and trillions of years. Consider how long a black hole lives. A star may shine for millions of years. A galaxy may evolve over billions. But a black hole, especially a supermassive one, can persist for timescales that stretch far beyond our everyday sense of duration. Long after stars like our Sun have exhausted their fuel, long after galaxies have changed shape, black holes remain. They are among the longest-lived structures in the universe. This longevity gives them a quiet authority, not power, but endurance. They witness epochs pass. They observe galaxies collide and separate. They remain as the universe changes around them. And yet, even this endurance is temporary. The universe allows nothing to last forever, over incomprehensible spans of time. Hawking radiation slowly carries energy away, particle by particle, wave by wave. The black hole loses mass. The process is unimaginably slow for a supermassive black hole. It takes longer than the current age of the universe, multiplied by itself many times over. But the direction is clear. Eventually, the black hole fades, not with violence, not with drama, but quietly. The final moments of a black hole's life are not explosive for large black holes. They simply diminish, growing warmer as they shrink, until at last they dissolve into radiation. The energy they once contained spreads outward, becoming part of the cosmic background. In this way, black holes return what they borrowed, Nothing is hoarded forever, and this speaks to a deeper rhythm in nature. Everything gathers, everything transforms, everything returns. Now let's turn our attention gently to the idea of stillness. When we imagine black holes, we often imagine motion, matter falling inward, disks spinning, jets erupting. But most of a black hole's existence is quiet. There are long stretches of cosmic time when nothing falls in. No gas, no dust, no stars. During these periods, the black hole is almost indistinguishable from empty space, and yet its presence is still felt. Space remains curved, orbits remain shaped, paths of light remain bent. The black hole does not need to act to have influence. This is a powerful idea because in our own lives, we often feel pressure to act, to move, to produce, to respond. But the universe shows us that presence alone can be meaningful. Sometimes, simply being is enough. A black hole does not announce itself. It does not seek attention. It does not demand recognition. And still, it shapes the cosmos. Now let's explore another subtle idea: symmetry. Black holes are surprisingly simple objects. Once formed, they lose almost all distinguishing features. No matter what falls in, a star, a planet, a cloud of gas, the black hole settles into a state described by just a few parameters: mass, spin, charge. This is sometimes called the no-hair theorem. The idea that black holes have no additional features, no memory of what formed them beyond these simple quantities. This simplicity is striking. Complex beginnings lead to simple endings, and that simplicity is stable, predictable, reliable. In a universe filled with complexity, black holes represent a kind of clarity. They strip away details, leaving only essentials. There is something calming in that. It suggests that complexity is not permanent, that under the right conditions, systems simplify, they settle, they resolve. Now let's return once more to the idea of connection across time. The black holes we observe today were formed long ago. Many were born when the universe was younger, when stars were larger, when conditions were different. They carry the history of the cosmos within their mass, and the matter inside them once participated in other stories. Atoms in a black hole's accretion disk may once have been part of a star. That star may have formed from a cloud enriched by earlier supernovae. Those supernovae may have scattered elements forged in even earlier generations of stars. Time folds in on itself through matter, and you are part of that same folding. The atoms in your body share that history. They have traveled through stars, through explosions, through planetary systems, through living beings. They are ancient travelers, temporarily arranged. Here, now. This is not metaphor. It is physics. Black holes and people are connected not by meaning, but by origin. by shared material, by shared laws. We are all expressions of the same universe, experiencing itself in different ways. Now let's pause and allow that thought to settle. You are not separate from the cosmos. You are not observing it from outside. You are inside it, shaped by it, participating in it. When you feel gravity, that is the same force shaping black holes. When time passes for you, it follows the same rules that slow clocks near event horizons. When light reaches your eyes, it has traveled through curved space-time, bent by massive objects along the way. The universe is not distant, it is intimate. Now let's consider uncertainty. Black holes are places where certainty breaks down, where prediction becomes difficult, where our equations give answers, but not complete ones. And yet, the universe continues even when we do not fully understand it. This is important. Understanding is not a requirement for existence. Certainty is not necessary for peace. The universe does not wait for us to explain it. It unfolds regardless, and that unfolding is stable, lawful, calm. We can take comfort in that because it means not knowing everything is not a failure. It is simply a condition of being part of a vast system. Black holes exist whether we understand them or not, and so do we. Now let's slowly shift toward rest. As this journey continues, the ideas may begin to blur, details may soften, concepts may drift out of focus. That's perfectly fine. You don't need to hold on to them. Let them float like distant stars, barely visible, but present. If sleep begins to arrive, welcome it. If wakefulness remains, that's fine too. There is no goal here, only motion, gentle, steady, forward, just as matter moves through space-time, just as black holes follow their paths. You are following yours through this moment into the next, and wherever that path leads tonight, it is safe, because the universe, even at its most extreme, is orderly, and you are part of that order. As these thoughts continue to drift, the universe itself seems to breathe, slowly expanding, quietly changing, without urgency. Black holes move through this expanding cosmos as anchors of gravity. They do not resist the universe's growth. They simply exist within it, adapting, responding, remaining consistent as everything else stretches outward. Expansion does not pull black holes apart. Gravity binds them internally. The universe grows, and black holes go along for the ride. This balance between expansion and gravity is one of the great harmonies of cosmology. Space itself stretches, while gravity gathers. One spreads things out, the other draws them together. Neither wins completely, both coexist. And within this balance, structure emerges. Galaxies form filaments. Clusters arise at intersections. Vast voids open between them. On the largest scales, the universe resembles a cosmic web. Long strands of matter, glowing faintly, stretching across unimaginable distances. At the nodes of this web, galaxies cluster, and at the centers of many of those galaxies, black holes quietly reside. They are not rulers of this structure. They are participants. Gravity shapes the web, but gravity itself is shaped by mass. Everything influences everything else. Gently, persistently. Now let's slow even further and think about motion without urgency. Nothing in the universe rushes, even light, the fastest thing we know, moves at a fixed speed. It does not hurry. It does not accelerate beyond its limit. It simply travels steadily across space. Black holes follow the same principle. Matter falling toward them does not snap inward. It spirals gradually, tracing elegant paths dictated by geometry. Orbits decay slowly. Energy is released over time. The universe favors patience. This can feel surprising, especially from a human perspective. Our lives are short. Our schedules are tight. Our days feel rushed. But the cosmos operates on a different clock. Black holes teach us this simply by existing. They remind us that meaningful change does not require speed. It requires persistence. Now let's reflect on quiet certainty. Despite their mystery, black holes are among the most precisely described objects in physics. Their behavior follows exact equations. Their properties are constrained. Their evolution is predictable. There is comfort in that, because it means that even where things seem unknowable, there is still structure beneath. The universe is not chaotic at its core. It is ordered, even when complex. And this order does not demand attention. It does not announce itself loudly. It operates in silence, beneath appearances, much like sleep itself. When you fall asleep, countless processes continue. Your heart beats, your lungs move air, your brain shifts rhythms, all without conscious effort. Order persists, even as awareness fades. The universe does the same. Black holes do the same. They continue, regardless of observation. Now consider distance again. The space between objects in the universe is vast, immense. Most of existence is separation, and yet nothing is truly isolated. Gravity reaches across distance. Light travels across emptiness. Time connects moments. Black holes may seem isolated, but they are tied to everything around them. Their gravity influences stars far away. Their mergers send waves across the cosmos. Their radiation, faint though it is, eventually reaches distant space. Connection does not require proximity, and this too is comforting, because it means even when things feel far away, disconnected, separate, they are still part of a larger whole. Now let's turn inward, gently. Your body exists within gravity. Your time flows within space-time. Your atoms obey the same laws as stars and black holes. You are not outside physics. You are not apart from the cosmos. You are a small region where the universe is temporarily aware of itself. This awareness does not need to be sharp. It can soften. It can fade. It can drift into sleep. The universe does not require your attention to continue. It carries on, calmly, steadily, regardless. And that means you can rest. Now think about endings. We often associate black holes with endings, but as we've seen, they are not final states. They are phases, long-lived, but temporary. Stars end, become black holes. Black holes end, become radiation. Radiation spreads, cools, thins. Everything transitions. There is no permanent stopping point, only change. This perspective can soften fear because it means nothing is trapped forever. Not matter, not energy, not even black holes. Everything moves forward, transforms, dissolves, and becomes something new. Even the most extreme objects obey this rule, and so do we. Our moments pass, our thoughts change. Wakefulness turns into sleep, sleep into dreams, dreams into morning, cycles within cycles. Now let's imagine far into the future, a time when galaxies have drifted apart, when star formation has slowed, when most matter exists as faint remnants, white dwarfs, neutron stars, black holes. The universe is darker then, quieter, cooler. Black holes dominate mass, but not activity. They sit, isolated, separated by enormous distances, rarely interacting, rarely merging. Time stretches, and slowly, unimaginably slowly, Hawking radiation continues. Black holes shrink, one by one. They fade. The universe becomes emptier still, but not unstable, not violent, just quiet. This vision is not meant to disturb, it is meant to calm, because it shows that the universe tends toward stillness, not chaos, toward balance, not explosion. And that trajectory includes everything. Now return gently to the present, to your breathing, to the surface beneath you, to the quiet around you. You are safe. You are supported. You are part of a universe that knows how to persist without urgency. Black holes teach us not about destruction, but about patience, about endurance, about the power of simple laws applied consistently. They show us that even extremes can be calm when viewed correctly. So let your thoughts slow. Let the edges blur. Let awareness soften. There is nothing to solve, nothing to fix, nothing to hold on to. Just motion, gentle, forward, and wherever this moment carries you next, whether into deeper rest or quiet wakefulness, it is part of the same cosmic flow, the same flow that shapes galaxies, same flow that shapes black holes, the same flow that carries you. Now, as this journey continues, everything begins to soften even more. Details become less important now. Edges blur, ideas loosen their grip, and float more freely. This is how the universe often reveals its deepest truths, not through forceful clarity, but through gentle repetition, quiet rhythm, and slow familiarity. Black holes, once framed as dramatic and extreme, now begin to feel almost ordinary, not because they are small or simple, but because they obey the same rules as everything else: gravity, energy, time, conservation. There is no special exception written into the universe for them. And that realization brings a kind of peace, because if even black holes are governed, then chaos is not in control. Law is, balance is, continuity is. Now let's rest with the idea of belonging. Every black hole belongs exactly where it is, formed from local conditions, shaped by surrounding matter, evolving in step with its environment. None are misplaced, none are accidents, and the same is true for you. Your presence here, in this moment, is not separate from the rest of reality. You are not out of alignment with the universe. You are not late or early or off course. You are exactly where the unfolding of countless causes and effects has led you, just as stars form where gravity gathers gas, just as black holes form where stars collapse. You exist where your path has brought you. There is no need to resist that. Now let's gently revisit time. One last time. Time does not rush. It does not hurry you. It does not demand urgency. Time simply flows. Near black holes, it flows differently. Slower in strong gravity, faster, far away, but always forward, always consistent with the structure of space-time. Time is not an enemy. It is a dimension you move through, like space. And just as you can rest in space, you can rest in time. Sleep is not a pause in time. It is a different way of moving through it. When you sleep, time continues, but awareness softens. The mind lets go of tracking each moment, and that is not loss. It is relief. The universe does not require constant attention. Black holes exist whether they are watched or not. Stars burn whether they are named or not. Time passes whether it is measured or not. You are allowed to rest without missing anything essential. Now let's think about quiet strength. Black holes are sometimes described as powerful, and they are, in terms of gravity. But their power is not aggressive. It is passive. It does not reach outward. It waits. It is strength through presence, not through action. And that kind of strength exists everywhere. The ground beneath you holds you up. Without effort, the air around you supports your breathing. Without sound, gravity keeps you anchored. Without demand, the universe is full of forces that do their work quietly. You do not need to push. You do not need to strive. You do not need to force rest to arrive. It comes when resistance fades. Now let's allow the language to slow even more. Sentences stretch, pauses lengthen, thoughts arrive and drift away without needing to be followed. Black holes, in the deepest sense, are lessons in surrender. Matter does not fight gravity forever. Eventually, it yields, not in defeat, but in accordance with natural law. Yielding is not failure. Yielding is alignment, and sleep is a kind of yielding, a gentle acceptance that this moment does not require control. You can let go. The universe will continue. Now imagine, for a moment, drifting far from everything familiar. No body, no labels, no history. Just awareness, floating within space-time. Stars glow faintly in the distance. Galaxies stretch across darkness. Black holes sit quietly, curving space. Without sound, there is no danger here, no urgency, no demand, only presence. This is not a place you must reach. It is a feeling you can allow, a sense of vastness that makes small worries loosen and fall away. In a universe this large, nothing needs to be solved tonight. Now let's bring that vastness closer. The same laws shaping galaxies shape your body. The same gravity curving space-time holds you gently to Earth. The same time flowing past black holes carries you toward rest. You are not separate from these forces. You are their expression at a human scale. And that scale is valid. Small does not mean insignificant. Brief does not mean meaningless. A moment of rest is just as real as a billion years of cosmic evolution. Now we move toward quiet closure. Not an ending, but a soft settling. The kind that doesn't announce itself. If sleep has already arrived, let these words fade. If wakefulness remains, let it be calm, unbothered, unhurried. There is no wrong way to be here. Black holes teach us that even the most extreme places in the universe are governed by order, patience, and consistency. They teach us that mystery does not imply threat, that darkness does not imply danger, that silence does not imply absence. Sometimes, silence is simply space, doing what it does best, holding, and you are being held by gravity, by time, by the quiet reliability of physical law. Nothing needs your effort right now. Nothing is waiting for a response. Just breathe, slowly, naturally. Let the universe do the work. Let the mind soften. Let awareness drift. And if thoughts arise, let them pass, like distant stars sliding across a night sky. No need to follow them. No need to stop them. Just rest, in motion, without effort. The cosmos continues, and you are safe within it. Sleep well, traveler. Dream of gentle curves in space-time, of light bending softly, of time flowing peacefully. Remember, you are stardust. You are ancient. You are temporary. You are part of something vast and calm and enduring. Rest now. Good night and sleep well.